Okay, the final example here in chapter 5.2, this one has an absolute value bars to it. If you recall, absolute value bars just make everything reflect up above the x-axis. So if there's any negative solutions to this, it's going to reflect up to become a positive solution. And when I'm graphing an absolute value function, if I determine what makes the contents equal to 0, so 7 divided by 2 is 3.5. And notice that 3.5 lives in this interval. It's between 1 and 4, which means I'm going to have to include it. That's the one number I really want to have in my chart. So if I'm doing an XY chart again, I want to make sure 3.5 is on it. If I put 3.5 in for x, 3.5 times 2 is 7, minus 7 is 0. Absolute value is 0 is 0. If I pick something bigger than 3.5, such as 4, and I wouldn't want to pick anything bigger than 4 because that's the top of my interval. 4 times 2 is 8, 8 minus 1 is 1, the absolute value of 1 is 1. If I pick something less than 3.5, let's go with 3 or 2 or 1. I wouldn't want to go below 1 because 1 is the bottom of my interval. So double it, subtract 7. So 3 times 2 is 6, minus 7 is negative 1. Absolute value bars make it positive 1. 2 times 2 is 4, minus 7 is negative 3. The absolute value bars make it positive 3. 2 times 1 is 2, minus 7 is negative 5. The absolute value bars make it positive 5. Just like that, we can get as many points as we need to graph it, but I need to have this point because that's going to be the point of the graph. So anytime you're doing an absolute value, it's going to have a sharp turn. That sharp turn happens where that content equals 0. Looking at this, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go at a half scale on the x-axis. We have to go up to 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's enough room to go 0.5 on the y also. You can scale a little bit to allow your graph to be a little bit bigger so you have room to write stuff in it. It's sometimes helpful. So if I go 3.5 comma 0, 0.51, 0.52, 0.53, 0.50. We have 4, 1. We have 3, 1. We have 2, 3. 1, 2, 3. And we've got 1, 1, 2, 3, 4, 5. And if you need to mark it as such, sometimes we lose touch of our ideas of where things are at. So if you actually want to write things in here, you can kind of get a feel for where things are. Looking at this graph, this is where I'm starting, this is where I'm ending. If I were to connect those dots with a segment, like so, starting here, going to here, and then going back up here. The entire graph's above the x-axis, but I've got one triangle happening right here. I've got a second triangle happening right here. So even though everything's above the x-axis, I've got to find this area and add those two areas together. And if I were to establish my triangles here, let me just highlight them a little bit so they will stand out a little bit better. I got a C minus on my art project there. I went outside the lines a lot. The length of the base here is 1, 2.5. The height is 1, 2, 3, 4, 5. So the dimensions of the blue triangle are 2.5 and 5. The dimensions of the red triangle, or the yellow triangle, are, this is 0.5 right here, and that's 1 right there. So we have the dimensions very easily figured out. The area of the blue triangle is going to be 1/2 times 2.5 times 5. So that's going to be 6.25. Half of 5 is 2.5. 2.5 times itself is 6.25. The area of the yellow triangle is going to be 1/2 times 0.5 times 1. And that's just going to be 0.25. Half of 1 is a half. Half times a half is a fourth, which is 0.25 is a decimal. So then I'm able to write the answer then. So area from 1 to 4 of the absolute value of 2x minus 7 with respect to x is going to be the blue triangle added to the yellow triangle. So it's going to be 6.5. So in general, to do these problems in your homework for this section, graph this equation from here to here. identify what shapes are in your picture. They're going to be triangles, rectangles, trapezoids, portions of circles. Apply those area formulas of those things in order to find the overall area. Any area happening below the x-axis, such as the first example I showed you, is a negative area. So if it's below the x-axis, it will be a negative area. If it's above the x-axis, a positive area. Once you get the areas either positive or negative, add them algebraically, add up to the same sign, subtract the different signs. So that's how the problems are going to work today, and hopefully that makes enough sense that you can tackle that assignment.